Hi everyone. In this video, we'll see the problems on buoyancy. The first problem is find the density of metallic body which floats at interface of mercury and water such that 35% of volume submerged in mercury and remaining part in water. See, first we have to understand the problem like what we have to find. We have to find the density of a metallic body. That metallic body is floating on an interface between mercury and water. Say we have two different liquids here. One is mercury, another one is water. Correct? A body which is floating like this. Don't worry about the shape of the body. Okay. So such that this part is there in the water. So this amount of the body is in mercury, that he has given that 35% of the volume, 35% of the volume is in mercury. The remaining part, that is 65% of volume is in water. If I take 100%, that is 35% is in mercury, the remaining 65% is in water. You have to find what is the density of this body. So density of the body means it is specific weight. Gamma of the body is unknown in this case. Correct? Okay. So we know that the buoyancy force is nothing but the weight of the metallic body, which is the weight of the metallic body is equal to weight of the water displaced. That is, I'll write here, weight of that body is equal to. So here there are two different medium of the fluid. One is mercury, another one is water. We know that this amount of the body, that is 35% of that body, will displace as mercury. The remaining 65% will displace as water. Therefore, weight of the body is equal to weight of water displaced, correct? Weight of water displaced plus weight of mercury displaced. Okay, is weight of water displaced plus weight of mercury displaced. Okay, so let me consider V, which is equal to the volume of the body. Okay, volume of the body. So we know that the weight of the body is given by density of the body multiplied by volume V. Okay, that is the volume we have taken, which is equal to weight of water is equal to density of water multiplied by volume of body in water, correct? Plus weight of mercury displaced is, that is density of mercury into volume of body in mercury, correct? So this density of body is unknown into V, which is equal to density of water is nothing but 9810 multiplied by volume of body in water is 65%. That is 65 divided by 100 into volume, that is 65% of the volume. Okay, plus what is density of mercury? That is 9810 into 13.6. That is 13.6 is the specific gravity of mercury. So you need density of any material is nothing but the specific gravity of that material multiplied by 9810, that is density of water. That multiplied by volume is 35 divided by 100 into what? V. Correct? Now this V will cancels. Therefore, the gamma of the body, if you simplify this, 9810 into 65 by 100 plus 9810 into 13.6 into 35 by 100, it works out to be 53.07 into 10 to the power of 3 Newton per meter cube. This is the answer. Okay, you remember one thing, In case of the buoyancy problems, you just remember this equation. Weight of body is equal to weight of the water displaced by that body plus weight of the mercury displaced by that body. Okay, so in case if there is only one liquid, it is completely submerged, then weight of the body is equal to weight of the fluid displaced by that body. That is the general equation. Then weight is obtained by density multiplied by volume. If substitute correspondingly, you will get the density of the body. Now, the second problem, a metallic cube of 30 centimeter side and weighing 450 Newton is immersed in a tank containing of water and mercury. Determine the position of the cube at the water-mercury interface when it has reached equilibrium. See, there is a tank. Okay, so in this tank, we have an two liquid, that is, one is mercury, the another one is water. Okay, since the density of mercury is high, it will settle at the bottom. So a metallic cube is immersed in this tank in such a way that it will be at the interface of this two liquid. The dotted line indicates the interface of these two liquids. Okay, so is completely immersed. So some portion is immersed in the, it is in the water, some portion which is in the mercury. It has 30 centimeter side, therefore side is equal to 30 centimeter, which is nothing but 0.3 meter. So each side is the having an dimension 0.3 meter because it is a cube, all the dimensions are same. So let me take that the amount of, or the depth of immersion in the water, I'll take it as H1. The depth of immersion in the mercury, I'll take it as H2. Correct? So depth of immersion, H1 indicates the depth of the cube in water, H2 indicates the depth of the cube in mercury. So only this volume is in water, the remaining volume is in mercury. Okay, so side is clear, H1, H2 is clear. Then we have an formula, that is weight of the body is equal to weight of water displaced plus weight of mercury displaced. Correct? So therefore, weight of the body he has given, that is 450 directly, because in the previous case you are finding the density. So but in this case he has given the weight directly. If you want to write it the side, that is weight is equal to 450 Newton. Okay, then weight of the water displaced is obtained by density of water that multiplied by volume of body or the cube immersed in water. Correct? So this is one. Then plus weight of mercury is nothing but density of mercury multiplied by volume of body in immersed in mercury. Correct? Now this 450, which is equal to, what is gamma of water? That is 9810 into what is the volume of body immersed in water? You observe this, the volume is, it is a cube. This is 0.3. Okay, that multiplied by the another dimension is also 0.3. That is 0.3 into 0.3 into what is the depth? It is H1. That is the volume. Okay, this is the volume. Plus density of mercury is 9810 into 13.6 into volume of body in mercury is what? 0.3 into point, that is area of the cube, that multiplied by the depth, that is H2. It becomes 0.3 into 0.3 into what? H2. Okay, to simplify, keep the unknown quantities as it is, that is 9810 into 0.3 into 0.3 works out to be 882.9 times H1 plus 9810 into 13.6 into 0.3 into 0.3 works out to be 12007.44 multiplied by what? H2. Call this as equation 1. Okay. Now you observe the figure. In this figure, this is a cube. The cube having an equal dimension of 0.3 meter. So the total depth of the cube is also what? 0.3 only. Correct. Now, from figure, we can write H1 plus H2 is equal to what? 0.3. Call this as equation 2. Because the total depth is 0.3, we need to find what is the position, means what is the depth of immersion in water, what is the depth of cube that is immersed in the mercury. We have to find H1 and H2. So I got one more equation from the figure. Now you observe the equation 1, 2. It is a simultaneous linear equation. Simplify these two equations, you will get H1 as 0.28 meter, H1 as 0.28 meter, and H2 is equal to 0.02 meter. Okay, so H1 is 0.28 and H2 is 0.02 meter. That is the position where the cube is lying at the interface of the water and mercury when it has reached equilibrium. This is how we should solve the problem of the interface between the two fluids. The problem 3. A wooden block of specific gravity 0.7 and size 2 meter by 0.5 meter by 0.25 meter is floating in water. Determine the volume of concrete of specific weight 25 kilonewton per meter cube that may be placed on the wooden block, which will immerse. The first case is wooden block completely in water. Second case is wooden block and concrete completely in water. See, in this problem, so I'll write the figure. There is a wooden block, okay, which was floating in the water. See, floating means it is some portion is under the water, some portion which is in the air. Here the width is 0.5 meter. The depth he has given as 0.25 meter, and 2 meter is the another dimension. There is a wooden block which is floating in the water. What they'll do is they'll place some concrete on it. See, for this wooden block, I'll place some concrete, okay, like this. The density of this concrete is what? 25 kilonewton per meter cube. So when you place the concrete like this, the case 1 says that wooden block completely in water, means the wooden block will be completely immersed in the water. Okay, so the entire portion of this wooden block, that is 0.25 meter, will be under the wooden block. You have to find, okay, so what is the volume of this concrete? What is the volume of concrete you have to place in order to immerse this wooden block completely in water? That is what the first case. The second case is you have to find the volume of the concrete such that both wooden block and the concrete completely in water. So let me take the case 1. Okay, so what is the details he has given? He has given the volume. Okay, so volume of the block, which is equal to 2 into 0.5 into 0.25 meter cube. Correct. So he has given specific weight, that is gamma of concrete, which is equal to 25 into 10 power 3 Newton per meter cube. Gamma of concrete is 25 into 10 power 3 Newton per meter cube. So we know that, so I'll write here, that is weight of water displaced. Okay, so weight of water displaced is equal to, you observe the sketch, Now this completely wood is in water. The weight of the water displaced, which is equal to what? Weight of the wooden block plus weight of the concrete. Correct? So weight of the water displaced is which is equal to nothing but the weight of the wooden block plus the weight of the concrete. Okay, so what is the weight of water displaced? Weight of water displaced, be careful, weight of this water displaced is equal to the, okay, so weight of the water displaced by the wood only. This weight of water displaced, which is obtained by the density of water multiplied by volume of the water, the volume of the water displaced by the wood. Why I have taken only the wood? Because only the wood is immersed in the water. Therefore, the weight of the water displaced works out to be gamma of water multiplied by volume of water, displaced by wood. Okay, this is very, very important. Gamma of water into volume of water displaced by wood. This is this one, which is equal to weight of wooden block. Weight of wooden block is nothing but the density of wood multiplied by volume of wood. Okay, plus this one is this one. Weight of concrete is gamma of concrete multiplied by volume of concrete. Correct? So let me write here. The gamma of water is how much? 9810 into volume of water displaced by the wood. Volume of water displaced by the wood is given by 2 into, that is the volume of the wooden block, into 0.5 into 0.25. Volume of water displaced by wood, which is equal to the volume of the wood only. Correct? So to take only this one, which is equal to, what is the density of wood here? So density of wood, he has given the specific gravity of wood as 0.7. Therefore, it becomes 9810 into what? 0.7 into volume of wood is 2 into 0.5 into 0.25. Plus, what is gamma of concrete? Gamma of concrete he has given, that is 25 into 10 power 3. The volume of concrete is unknown. That is only you have to find. I'll take it as V suffix C is the volume of concrete. Okay. You simplify this one, 98102 into 0.5 into 0.25 is equal to 9810 into 0.7 into 2 into 0.5 into 0.25 plus 25 into 10 power 3 into VC. If you simplify for VC, it works out to be 0.029 cubic meter. So you require 0.029 cubic meter of concrete in order to immerse the wood completely in the water. This is the first case. So what is the equation? What is the governing equation here? Weight of water displaced is equal to what? Weight of wooden block plus weight of concrete. Weight of water displaced is nothing but the weight of the immersed portion only. So therefore it is gamma of water into volume of water displaced by the wood, because only the wood is in water. This concrete is above the water. Therefore, don't consider this volume in this. You simplify, you'll get the VC. Now the second case, I take the second case. Okay, so what is second case? Wooden block and concrete completely in water. You have to find the volume of the concrete such that both wood as well as the concrete completely in water. Means this is the wooden block, this is the concrete. Now both is completely immersed in the water. Okay, so this depth is 0.25. You have to find what is the volume of concrete required such that both wood as well as the concrete will be under the water. Okay, the same governing equation you have to take here. That is what we have written earlier is weight of water displaced is equal to weight of water displaced by wood plus weight of water displaced by concrete. Okay, or else you can directly write weight of the wooden block plus weight of the concrete, because weight of water displaced by the wood is nothing but the weight of the wood only, in case that is due to the Archimedes principle, what he says, the same thing. So therefore here the weight of the water displaced, here you observe the sketch now, both concrete as well as the wood is under the water. Therefore this weight of the water displaced is nothing but the density of water multiplied by volume of water. Okay, so be careful in this time. It is volume of water displaced by both wood and what? Concrete. Okay, this is what I told here, because both wood and concrete is in water. Then this is same, weight of water displaced by wood is gamma of water multiplied by volume of wood plus gamma of concrete multiplied by volume of concrete. Correct? Now we substitute all the values. What is gamma of water? It is 9810 into. Now be careful here. Volume of water displaced by wood and concrete is nothing but volume of wood plus volume of concrete. What is volume of wood here? That is 2 into 0.5 into 0.25 plus what is volume of concrete? It is VC. So now you observe volume of wood plus volume of concrete multiplied by the density of water. You have to consider both, which is equal to what is gamma of water? 9810 into volume of wood is 2 into 0.5 into what? 0.25 plus gamma of concrete. He has given as 25 into what? 10 power 3 into what? Volume of concrete VC. Now in both left hand side as well as right hand side, you have an volume of concrete. Therefore, you simplify this, we get the volume of concrete VC works out to be 0.048 cubic meter. So you require 0.048 cubic meter of concrete in order to immerse both wood and the concrete completely. So in this case, let me tell you one thing. It is for this, the volume of concrete required was 0.029 cubic meter. In this case, volume of concrete required is 0.048 cubic meter. So this is how you should approach the problem. You have to solve accordingly. Okay. Thank you for listening.